DML Part 2 of 4. In this nugget, we begin to move from the select statement, which we saw in the previous nugget is used primarily for data retrieval, to some true data manipulation language statements, the first of which is going to be insert. As we're going to learn, the insert statement is awfully useful for adding new rows to a database table. I'll show you two different syntactical options for insert that come into play in different scenarios. I'll also show you the MySQL specific replace statement, which kind of serves as a one-stop shop when you want to replace the contents of an existing row in a data table. Let's get going. As previously stated, the insert statement is used to add new rows to a database table. Insert, it should be stated, is a standard ANSI ISO SQL term, just like the select statement it is. And in MySQL specifically, there are two syntactical variations for insert that you should be aware of, not just for your MySQL certification exams, but for your lives as DBA administrators. Now, to jump right into the syntax, to insert a new row into a table in MySQL, we say insert into the name of the table, and then optionally, in parentheses, you can specify the columns that you're inserting. So in this case, we could be really formal and assume that this employee table has three columns, ID, LN, and dept ID, and we're just specifying as clearly as possible in advance that we are in fact going to insert data into all of those columns. Next, we specify the values keyword, and then in a parenthesized list, one or more rows to which you're inserting into that table. Therefore, in this case, we're inserting a row where the ID will be 10, LN will be Jones. We'll want to put single ticks around Jones since it's a string value just to be formal, comma, and then we're putting in a department ID of 20. Now, I said that the column list is optional. Best practice, in my humble or not so humble opinion, is to always include your columns in your insert statement. It's possible to get away without using them, but you have to be really careful and you have to be really on top of the data in your table. Nulls, defaults, and column order are all respected out of the box in MySQL. In other words, if we run statement 2, insert into emp, we don't specify columns, but just use a values statement and pass in one or more values, then what's going to happen is that insert is going to substitute any null values or default values that are available. In other words, if our ID column is not specified, which it's not here in the second statement, then as long as that ID column is set to, say, auto increment, which is in the sense kind of a default value when you think about it. In other words, each new row will have an ID value that's incremented by +1. That would happen in this case. And also, let's see, we're missing a last name column. As long as the last name column wasn't specified at creation with not null, then MySQL would by default put a null value in the last name column. So to sum up, the second statement would create an ID value of the next positive integer. The first name, well, let's just assume that there's first name and last name. The first name would come in as harder since the column order is respected. If there's a last name and you don't specify anything, a null would be sent to that column. And then finally for department ID, we have in this case 20. Now, that sounds kind of complicated, doesn't it? And it is complicated when you're not specifying those columns, as I said, because, well, there's a couple reasons. Number one, if you specified not null for a column and you don't specify it in your values list, you're going to get an error. And this could also cascade to some big problems if, for instance, you're putting in multiple rows in a single insert statement. Depending upon the storage engine that you're using, you may recall that MyISOM is not a transaction-oriented storage engine. So if we're using an insert statement and populating, say, 10 rows, and there's a syntax error on row 6, well, the first 5 rows may very well be committed into the database. That's MyISOM for you. It doesn't support transactions. On the other hand, if that table were using a storage engine like InnoDB that does support transactions, then a syntax error halfway down your insert list would result in the entire transaction getting rejected, you see? Therefore, to repeat one more time, I find in my experience as a DBA, the best way to go with inserts is to specify the columns explicitly and address all of those columns in your value list. Now you can use the default keyword. For instance, we could say insert into emp ID ln department ID values default comma, then we could put some last name, and then comma default. And as long as that column had a capability of populating with either a default value or a null value, we'd be okay. For ID, we'd be okay because saying default in our statement would result in an auto increment, just a new integer value being given to us automatically by MySQL. And if we specified default for department ID, as long as we had a default value set for that column definition, then that default would be populated automatically. Now, if we did not have nulls enabled for department ID, and we did not have a default value, then that particular statement would fail. I'm hoping that all of these comments I'm making will become clear in Technicolor once we get to the demo portion of this lesson. Now then, I've just shown you the first of two syntactical variations for insert, and that is where we say insert into the table, optionally our column list, values, and then a parenthesized set that's going to correspond to a row insert. The second way to do your insert syntax in MySQL is to write insert into destination table and then use the set statement. The key take-home message, friends, the key difference between these two syntaxes is that you will use the set syntax if you were putting in just a single row and you are explicitly labeling each column using the assignment operator equals. The reason why I myself tend to like the values method is, as we'll see in the next whiteboard slide, this is the syntax you would use if you wanted to perform multiple row inserts in a single statement. The set statement here is limited to just a single row's worth of data. Some DBAs may like this though, because for a transaction-oriented database, you would simply write an insert set combination for every row, and without having to repeat or separate values, you could make an immediate assignment between a column and a particular value. So in a sense, this is easier to parse if you're just reviewing someone else's SQL code. But again, know that the difference is the set statement is limited to one insert. When you use the values, it's one or more inserts in a single statement. Now then, let's look at adding multiple records. How would that work? The thing here that can possibly confuse you that I want to straighten you out on is that when you do multiple records with a single insert statement, each row needs to be enclosed by parentheses. All right? That's the deal. So let's look at code sample 1. We're inserting into a table called personnel. We're declaring two columns here, first name and department ID. And then after the value statement, in this case, how many rows are we adding? Well, we're adding David, Chris, Wendy, Pat, Frank, Sam, and Sue. That's 7. So notice that we can just keep cranking our values all day long. However, we enclose each row set with parentheses, and we separate rows with a comma. In code sample 2, we have a way to perform a more robust insert where we're nesting a select statement into a destination table. So here we're saying insert into table 1, and instead of specifying discrete values, we're running a nested select statement that grabs all the rows and all the columns from table 2. Now what's implicit here, friends, and unstated, is that table 1 has the same column names and data types as table 2. But this can provide a really handy way to take a backup of a table, or if you just need to quickly populate a table for development purposes or for business analysis purposes, you can work on that copy of those rows without damaging the originals. Gotchas with any insert. One is watch your data types. Depending upon the SQL mode that your server is running in, which we discussed in earlier nuggets, so you should be pretty familiar with SQL mode, you may or may not find that some inserts either bail out with an error, or you get type conversions when you inadvertently give an incorrect data type. So make sure that you're populating your values in the same order that your columns are specified and that your data types are correct. Also, you should watch your primary and unique key constraints. We have to keep things in mind, for instance, for our primary key column, making sure that we never get a duplicate. If we inadvertently try to insert a row that has an already existing primary key value, well, that insert will obviously fail. Similarly, on the other side of a table relationship, if we have a copied column or a foreign key bound column, and we do an insert in there that refers to a non-existent value on the primary key side, that's going to generate a referential integrity violation, and that insert will also fail. Because it's so important, I'm going to mention it one more time. We have that issue of storage engines and transactional security. And this is especially important when you're doing multi-row inserts. If you're using MyISOM, you take the chances of some of your inserts going through and some of them failing, whereas with a storage engine like InnoDB, you can rest assured that if there's a syntax or data type error or column count error somewhere in the middle of your multi-row insert, the entire statement will be rolled back and you'll have a chance to give it a second try. Before we jump into the demo, I'd like to show you a MySQL specific term called replace that's really handy, but it's used in special cases that I'm about to explain. The replace statement is functionally identical to insert. In other words, you would use replace to add one or more rows to a data table. However, what replace does, it's kind of a bulldozer effect. In cases where we're using insert, if we inadvertently try to add a new row that contains a duplicate value, like let's say we have a row where the primary key for a certain row is 12, and we're inserting a new record that's going to also use, for let's say for the sake of argument, the ID value of 12. Let's say that it's a product definition for which the product has changed, but the ID value will remain the same. Now, how would you do that? If you just try to insert a new row using an existing ID value, the primary key constraint is going to stop you in your tracks. So typically what you'd need to do is delete the old row and then do an insert specifying that value, which should now be free. After all, if we nuke the ID 12 row, that would enable us to insert a new one using that 12 with new and different information for the other columns. And that'll work every day and twice on Sunday. But the purpose of the replace statement is to save you, the DBA, the extra work of doing those two statements when you can do it with one. So therefore, the replace statement force overwrites records with an existing primary key or unique constraint. So in this case, if we wanted to redefine ID 12 in our products table, we could use the replace statement, redefine our columns, use ID 12, and it would, in a sense, in one fell swoop, make the delete and insert happen in one shot. It's a very nifty tool. In our demonstration, we're going to create a sample database, create a sample table, and then work with the insert statement. We're going to use some particular data types and data type column properties in order to test the limits of insert, and we'll also use the replace statement so you're clear on its syntax. In this demonstration, we're going to work with the insert and replace statements to add new rows to a database table. We're on MySQL Nugget, that's the Windows Server 2008 box, and as you see, I've fired up an elevated command prompt and logged into MySQL Server. What I'm going to do is create a new empty database called IDB. That's shorthand for Insert Database. We'll then use IDB, and we're going to go ahead and create a simple table that contains, let's say, 4 rows that contain certain constraints that we'll be able to test with the insert statement. Let's take a look at the table I've created. I'm defining a table called emp, whose first column is ID. We're using the integer data type, unsigned, so it's positive values only. we're providing the auto increment property to make sure that for every new row, we automatically increment the last value by 1. And of course, this is not null. The not null is optional because, as you see on the next line, I'm providing the primary key constraint to the ID column. Second column is called first name, varchar 20. I'm providing a not null constraint here. Same with last name, same data type. The fourth and final column is salary. I'm using decimal, where we have a scale of 9 characters. So that would be 6, 7, 8. That would be up to $1 billion. That's quite a bit. And at 2 decimal places. And we're providing nullability here. However, we're doing a default value of 50,000. Finally, I'm specifying the MyISOM storage engine. All right, so now I can show tables, and I have my emp table. So let's get rocking and rolling with an insert. The first syntax I'm going to show you is the formal insert into with values option. So my statement is insert into emp. I'm not providing columns here. I'm living dangerously. And in my value statement, I just have to make sure that I have all 4 columns provided for in the proper order. Therefore, ID is going to be an integer. I'm providing default here to let my SQL provide the first value. Second column is first name, needs to be varchar. Then we've got last name. And then for salary, I'm going to sub in default. So take home message, you can use the default keyword, which is case insensitive, with columns that have a default value, allow you to use nulls, and or have the auto increment property. So if we do a select star from emp, we can now see that ID1, first name Tim, last name Warner, salary 50,000. All right, so why don't we change things up a little bit and this time say insert into emp, and we're going to provide columns, but this time let's just specify first name, comma, last name. First name, comma, last name. And then on the next line, we'll use our values statement. And this time, we'll just provide Susan, comma, Harder. Now, do you think that'll work? We're just specifying first name and last name in our column count. And in our values, we're specifying the appropriate data type, as we know, for those 2 columns. Told us that the query was okay. So if we run select star from emp, let's take a look and see what we have. Sure enough, we see that MySQL has incremented the ID just like it should and has provided the default value of 50,000. So far, so good. Now what happens if we do an insert into emp and specify our columns explicitly, and then in our values statement, we say 3 default default. How's that? So we're specifying all 4 columns, we're hard coding a value for ID, we're providing Jeff for first name, default for last name, and default for salary. What do you think? Well, if we run a select statement, we see that the default value was passed for last name, and in that case it was null, or nothing. All right, so if we want to add a last name for Jeff here, which is currently set to nothing, there's a couple ways we can go here. We can use the update statement, which would change or modify values in that row, but since we haven't yet gotten to that nugget, let's consider that we want to stay with insert. So therefore, why don't we try insert into emp, specifying all 4 columns, and in our value statement, we'll say 3 Jeff, and we'll provide Yeldon for a last name, and then let's say 100,000 for salary. What do you think of this? Nope, it didn't work. Duplicate entry 3 for key primary. So that's our primary key constraint coming in to save the day and provide row level integrity. However, we can use the replace statement, which has the same syntax as the insert, by the way. So we would say replace into emp, and in this case, I'm going to not use the value statement, but I'm going to try that other syntax, which is set, and then we just specify what we want to set. So ID equals to 3. Let's say first name is equal to Jeff, last name is equal to Yeldon, salary is equal to 100,000. That was fine. So let's select from emp again, and we see that we've now corrected Jeff's row using the replace statement. And I also kind of killed two birds with one stone there because I also showed you how the set statement works. And again, that works the same for insert or replace. It's just that we know replace is helpful because it can blow away the pre-existing row and replace it with the one we've put in there. To do a multi-row insert, as I already showed you, is just as easy as specifying more than one parameterized value list after the value statement. So in this case, I'm inserting into emp. I'm specifying the columns in order to be as strict as possible. And then after my value statement, it looks like I'm putting in 1, 2, 3 rows at once. Each row is parenthesized and separated with a comma. In order to make your code a little bit easier to read, notice that you can add interspersing spaces to separate your values. I like to do that just to make the code a little bit more reasonable. You'll also notice that I've made liberal use of the default keyword, especially for the ID column, because after all, the great beauty of auto increment is we take the blood, sweat, and tears out of trying to keep a unique value here and pass that on to MySQL. So therefore, assuming that my syntax is correct, I should be able to submit this batch to MySQL and have it come back okay, which it did, fortunately. So when we select against the table now, we have 6 rows. And while we're here, we might as well play around with the select statement. Why don't we select last name, salary, where salary is, say, greater than 100,000, and we'll order this by salary ascending. Well, sure enough, we have a problem with our syntax. Can you tell where the syntax problem is? Yep, it's between select and where. Well, I can use my history to bring back the first line, and then I'm just going to immediately throw in from emp. And then we can see if we've got where. Yep, we sure do. And then I'll use the up arrow again, see if we can bring back our order by statement. Yep, we sure can. So we can save ourselves some typing. Looks like in this case we have only one record whose salary is greater than 100,000, so really the order by doesn't work. Just wanted to bring back the select statement to refresh your memory in terms of how it works, especially when we use where to do filtering and order by to do sorting. Just for completeness, we're going to run one more insert statement using the set format, the set syntax. We'll say insert into emp, set, and we'll just say ID equals default, first name equals Tom, last name equals Nagurni, salary equals default. And let's see how that goes. That went fine. So that's just for completeness to show you again the insert into statement using the set identifier when you're explicitly putting in a single row. Let's finish this off with one more select statement, and there's our completed row set. Data Manipulation Language Part 2 of 4 Review. In this nugget, I'm hoping now you have not only the select statement in your regular DBA toolkit, but you also have the insert and replace statements as well. By now you should have a pretty clear understanding on what it takes syntactically to add new rows to a MySQL database table. You also know this really nifty replace command that can be used to substitute a delete and an insert in one fell swoop. You're making good progress so far, so I'd like to congratulate you on your work. I hope that this has been informative for you, and I'd like to thank you for viewing.